This is Srikant, working as assistant professor in electrical department. Now, I want to discuss about how to represent the alternative waveform or alternative current. So, before moving to the alternative current, I want to know about small difference between AC as well as DC. In DC, we have single phase 220 volts as well as integrated circuit purpose. We have 0 to 12 volts as well as the frequency is 0. Coming to AC, we have single phase as well as three phase. In single phase, we have 230 volts and three phase, we have 415 volts. And coming to frequency, that is 50 Hz to 60 Hz. In India, we have only 50 Hz. So that is the main difference between alternative current as well as direct current. Now coming to like waveforms, in direct current, it has a straight line. It's a straight line. And AC, coming to AC, we have positive and negative peaks. So positive and negative peaks we have. So positive half as well as negative halves. Now observe the diagram. In DC source, where you have the DC source, there we have the positive and negative terminals we have, and the direction is only one direction. Coming to AC, there we have phase as well as neutral, phase and neutral, and the current direction is both side. So that is the main difference between AC and DC. Coming to like waveforms, we have positive and negative polarity as well as different magnitudes at different time periods. So time period change, automatically your frequency value will be change. Generally, the waveform is alternative waveform is we have the positive and negative polarity. Current waveform or voltage waveform, any waveform, we have positive and negative polarity and with different magnitude at different time periods. So time period will change, automatically frequency will change. Now I have here x-axis is time. Just observe here, my x-axis is time, and waveforms, voltage waveform and current waveform. So the time period is same. So which time period we have voltage as well as current, both started and ended at same point, and magnitude is different. So voltage waveform magnitude is different and current waveform magnitude is different. Now coming to like parameters. So first one is cycle. What is a cycle? In any waveform, in any alternative waveform, we have positive and negative polarities. The set of positive and negative polarity is nothing but on cycle. Now in this waveform, from starting 0 to and ended up to this point. So positive peak as well as negative peak, positive peak as well as negative peak. So this total is nothing but up to this. This is one cycle. So in this total waveform, I have two cycles. So one positive peak and one negative peak, one positive peak and one negative peak. So we have two cycles. And coming to time period, so how many time periods we have? Same. So here time period is depending upon the where waveform is started and again where waveform started. So from this diagram, my waveform started here, again started here. So from this point to this point, your time period. Okay, from 0 to some 2 pi. So pi, 2 pi, 3 pi and 4 pi. So 0 to 2 pi, that is your time period. Clear? Now this waveform time period is this, and this is your second time period. So total two time periods we have. Suppose my waveform is, so this is my waveform. This is my waveform. Then what is your time period? So for this, my time period is, so started, my waveform started here, again started here. So same magnitude ma. So same magnitude. So my waveform started here, again started here. So this is my time period. Clear? This is my time period. If suppose my waveform is, this is my waveform now. So then what is my time period? So my time period is, my waveform started here, again started itself. Again started in this point. So my time period is, this is my time period. Simple. So where the waveform started again, in that axis where my waveform started again. So that is your time period. Now next one is wavelength. So I have some wave. So what is the wavelength for this waveform? The wavelength is depending upon the peak values. So between two peaks. So in this waveform, this is my peak, first peak and one more peak. So between these two peaks, distance nothing but your wavelength. Okay, same as your time period. Same as your time period. If you want to measure exact wavelength means between two peaks and coming to peak value. So what is a peak means? Where you have the maximum magnitude we have. So here my voltage waveform, this is my magnitude, maximum magnitude and negative side. So if you have the positive as well as negative we have. So positive, this is a maximum peak, and negative also this is a maximum peak. So for voltage waveform and current also, coming to current, this is a maximum peak. So peak value is depending upon the maximum magnitude. So just observe now. So that is my VM, maximum voltage value, and same thing maximum current value. And coming to like negative peak, so negative maximum current as well as maximum voltage values. So that is your peak values. And coming to like peak to peak values. So peak to peak value is where you have the positive peak to negative peak total value. That is your peak to peak value. So for voltage we have the positive peak and this is the negative peak. So total value, peak to peak value is your positive peak to negative peak. And coming to same as your current also. So positive peak current value to negative peak current value. And next one is your frequency. So frequency in AC we have like 50 to 60 Hz. In India we have the 50 Hz. And DC frequency is 0. Now for how we'll find the frequency value? So frequency is 1 by T. So 1 by time period. So your frequency depending upon the time period. So we'll know more introduction about frequency. So generally frequency is depending upon the number of waves. Clear? So number of waves. So I have some time period. So suppose this is my time period. In this time period, how many number of waves we have? So that number of waves is nothing but your frequency value will be changed. In that number of waves, your frequency value will change. Clear? Now, so I want to compare two waveforms at same time period. So your frequency formula is 1 by time period. So at same time period, I want to know about which is the maximum frequency, which is the lower frequency. So which is the higher frequency, which is the lower frequency. Now, I have, this is my one waveform. Same thing, at same time period, I have one more waveform. Okay, just observe now both waveforms. In first figure, we have how much time period we have. So my time period is now that waveform, first waveform, my time period is 0.02 seconds. So same time period. So same time period. That means same time interval. So how much time interval we have at same time interval? My t is for second also 0.02. So same seconds. So same second. Here I have only one peak, positive peak, only one negative peak. So we have only one cycle. At first figure we have only one cycle. Coming to second one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So totally we have 10 cycle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 cycles we have at same time period. So same time interval. So how much? 10 cycles we have. Clear? Now, in first waveform, what is your time period now? So I said time period is where the waveform started and again where the waveform started. Okay? Here my waveform started and maximum in second one. So here my waveform will be start. So up to this is my time period at first figure. So that is my time period. That is what is the value of that time period. That is total time. So how much we have? 0.02 seconds. 0.02 seconds. Now coming to like a second waveform. What is my time period now? So my time period is waveform started here. Again started in next. Okay, in total time we have 10 cycles. So this is my time period now. So waveform started, again where the waveform started. So in that point, that time is nothing but your time period. So for second waveform, my time period is how much? So 0.02 by 10. So 10 cycles we have. So total 10 cycles we have. So for this waveform, my time period is 0.02 seconds. Okay. First waveform, my time period is 0.02 and second waveform, my time period is 0.002 seconds. Clear? Now we have two waveforms. Now coming to like which is the higher frequency, which is the lower frequency now. So just observe which is the higher frequency, first one or second one. Just substitute those values in your formula. That's it. So what is your formula? 1 by time period. So your time period. So what is the time period for this first waveform? 0.02 seconds. So 1 by 0.02 will get like 50 Hz. Coming to second one, your value is 1 by 0.002 seconds. That is your time period. Now what is the value? That is 500 Hz. So which is the higher frequency now? The first one is lower frequency and second one is a higher frequency. Okay. So second one is your higher frequency. Just check the waveform. So where you have the maximum waves at particular time. Same thing in particular time, we have the less waveforms in first figure. In second figure, we have the 10 waveforms. That means 10 cycles at particular time. So that is your maximum frequency. And next, just observe the figure. So where we are utilizing, so where we are using the frequency, where we are using different frequency at different places. Just observe now. Here we have 10 kilometer. At 10 kilometer, that wavelength is decreasing. So from here to here, the wavelength is increasing, and automatically here the frequency is increasing. So both are opposite side. So wavelength is increased, automatically your frequency is decreased. Frequency is increasing, automatically your wavelength is decreased. So both are reverse. Now, so very low frequency, that is 3 kilohertz frequency you are utilizing in navis, as well as a 30 kilohertz frequency. Between 30 kilohertz you are utilizing like aeroplanes, where you have the towers. Medium frequency to higher frequency you are utilizing for radio frequency, and very high frequencies and ultra frequency we are using phone and TVs, as well as satellites. Satellites is utilizing which frequency means super high frequency, and very high frequency utilizing in different satellites. This is about the frequency where you are utilizing. Now moving to how to represent the alternative waveform. So how to represent the alternative waveform? So we know the alternative waveform is positive peak we have as well as negative peak we have. So how we'll get the positive peak and negative peak? So any method we have? Yes, it's a simple method. We know that in intermediate also. Just observe now. So in any magnetic field, we are rotating one coil or one single wire. So we'll get some magnetic force, EMF, electromotive force or electromagnetic force. So that is discovered by Michael Faraday. We know that is Faraday's electromagnetic induction, where you have the mechanical energy that is converted to electrical energy in form of rotation. Okay, here you can observe the figure. We have the north and south two magnets we have. So in that wire loop, we have the wire loop, and in magnetic flux, you can observe the magnetic flux also. And when we are the rotating the wire, we'll get the some EMF using two slip rings as well as brushes. So slip rings we have and brushes we have. So from this we'll get like some EMF. I have some video with 3D. Just check it now. Just observe this video. Okay, we have the magnetic fields in between our armature we have A, B, C, D. Just observe, and shaft to rotate armature to rotating purpose, and in magnetic field it's rotating. So using slip rings, this is the 2 slip rings and 2 brushes, and this is a galvanometer. Galvanometer means we need to know how much voltage you are getting. So armature is rotating between the field, magnetic field. So we will get the some EMF. So that EMF you can see in galvanometer. So what is the rule and how to get the sine wave? Just observe now. So using Fleming-Stainton rule, we know that. So A, B, C, D, we have some positive peak, and D, C, B, A, we have the negative peak. A, B, C, D, we have the positive, and D, C, B, A, we have the negative. So A, B, C, D, we have some positive peak we are getting, and when you have the D, C, B, A, we have the negative peak. Just observe. Simply we have the video. In that video we will get a t equal 0 seconds. So it's a B, C, D position. So there is no change of EMF. There is no change of your flux. Then we have the value at 0. Then it's rotating. So it's rotating. Automatically we have the some changes in magnetic field. So automatically it generates some EMF. So when the A, B, C, D, it's a vertical direction, then we will get the maximum peak. Again it's rotating. D, C, B, A, then it's moving to like 0. A T equal to T by 2. A T equal to T by 4, we have peak value T equal to T by 2, it's a 0. Again it's rotating. Then you will get the maximum peak, negative maximum peak. Then again it's coming to like starting position A, B, C, D. So it's moving to like 0. Yes. Clear? So this is your sine wave. We'll get the sine wave in this manner. So we have the north and south 2 poles we have. In between I have the one armature A, B, C, D, and when it's rotating, automatically we get the sine wave. The sine wave frequency depending upon the speed and strength of your magnetic field and armature also. Okay, so we'll go to the time periods and waveform. So just observe now. I have same north and south poles in different timings. So 0, 45, 90, 180, 270 and 360. In this point, what is the value? What is your sine wave? We will observe now. So at 0, so when you have the like a straight line, so straight A, B, C, D, 0 position. So 0 position, the value is 0, and 45 we have some value. At 90 we have the peak value. Just observe. So 0 to 360. 0 to 360 we have different values. Now observe now. So this is your waveform. So at 0 the value is 0. At 45 we have some 45, and 90 we have the maximum peak, and again 180 again 0. At 270 again maximum peak. 360 it's a 0. Now we can write the equation for this waveform. At 45 I have some value. At 90 I have peak value. So when you get the peak value at 90 means you can use the equation, that is Vm sin omega t or Vm sin theta. So that this is the equation for this waveform. Just substitute those values otherwise. So Vm is your peak value. This is my peak value Vm. Okay, Vm sin theta. So now theta value is 0. So sin 0 is nothing but 0. So Vm sin 0 is 0. Am I right? Now theta value is 90. Theta value is 90. Now sin Vm sin 90, how much we will get? So sin 90 is 1. We will get the maximum peak. Theta equal to 180. How much we will get? Again 0. Now theta equal to 270. How much we will get? Again minus 1. That means Vm minus Vm sin 270 is minus 1. So we will get the minus Vm. So minus negative peak. Then theta equal to 360. How much will you get? 0. So that is your sine wave. So for this waveform, this sine wave, you can write the equation Vm sine omega t or Vm sine theta. So you can write the time period or theta. So here omega is 2 pi f. Omega value is 2 pi f. So t is your time period. Omega is 2 pi f. So that means frequency. So omega is depending upon the frequency. So same thing theta also. So time period, different time period. Your waveform is depending upon the speed. I said like speed and strength of magnetic field and length of your coil. So armature, nothing coil, nothing but the armature. So this is about representation of your alternative waveform. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.